Hello everyone. I'm evaluating the possibility of doing a solar project on my home, and I need to know how our Generac backup generator automatic startup function operates. In other words, how does the generator start up automatically, and how does the transfer switch operate automatically? So I'm digging in to see what makes this thing tick. Then ultimately, I'll be installing a different way of making that all happen. Let's take a look.
Once I turn that power off, the grid power off, this line should be dead. No, it isn't. It's switched back. I don't quite understand how this functions, obviously. Let me turn that off. All right, we're back on generator power. So this is what the Guardian by Generac Power Systems transfer panel looks like. And I'm curious about how this thing operates because I'm planning to do some system upgrades on the house. So let's open it up and look inside and we'll see what makes this thing tick. So before I start messing with the power on the house, I'm going to shut off some of these breakers. I don't need all this electronic equipment turning on and off. So that's the air conditioner, compressor, living room, garage doors. Oh, and it just turned off a light over here. The cellar lights, nice. The sump pump's not running anyway. The furnace and the water heater, they're electronic. I'll turn those off. Laundry room, and it says bell. That's our bell, doorbell. Kitchen, dining room, garage. That must be garage receptacles. Basement plugs. Yeah, there's electronics plugged in there. Basement plugs. This one's still on. This light that I have on here is plugged into the bathroom GFCI circuit. There's a receptacle for it right behind me. So, which one is that? That says dishwasher. I'll turn that off. GFCI circuit. This light is likely to go off. Yeah. So we'll leave that one on. Those are all off. Won't hurt anything to turn that off. Lights. Well, it's not lights down here in these lights. Okay, so the only one that's on now is this circuit behind me that has this light on it that you see the shadow from. And I'm going to turn around to the main panel here and turn off the circuit for the barn. Oh, I hear some smoke detectors ringing. I wonder which one of those it is. Okay, the smoke detector stopped, but I don't know which one of these did it.
And yeah, it's on.
They stopped, right?
Yep.
Alright, it's this one. I can leave that on, except when I run the generator, it's going to go off again.
Okay.
It is? No, the generator will give it power. Well, we'll see. Right now, I'll leave it on. So out of these 16 spaces, I've got the GFCI circuit on. That feeds the bathroom, both bathrooms on the first floor, and this receptacle behind me that is providing that light. So I'm leaving that one on, and this one on, it just says lights, but that also controls the smoke detectors and CO detectors, and so if that's off, they're alarming. So I'm leaving that on for now. All right, let's open this up and see what's going on in there. So there's these 4 screws. They have a 3/8 hex head. Screws, or you could call them small bolts. They hold the cover on. And this isn't the first time I've had this off. This cabinet is very impressive. It's very heavy gauge steel. It's much heavier than the main panel box, or any main panel box I've ever seen. I was looking around online and I saw one of these listed somewhere used for $700. That was a little bit of a shock. Okay. There's information on the back of the panel there that I'll show you later and describe later. Okay, so the first thing I noticed when I looked in here before was that this section here is 16 space. It holds 16 breakers, and it's literally a Siemens panel board. And I actually found online that this panel board is literally used in some of their sub-panel boxes. So this is really a sub-panel. Then up here we have the transfer switch.
Generac transfer switch, rated voltage 250 VAC, rated current 100 amps.
And there's power coming from the generator here that goes into the bottom of the transfer switch, and power coming from the main panel here that goes into the top of the transfer switch. The power comes out of the middle of the transfer switch and goes and feeds this sub panel. Of course, there's the neutral here and the neutral that comes from the panel. So there's the neutral from the generator and the neutral from the panel right here. Now the thing that operates that transfer switch are these 2 coil solenoids. When they're energized, they pull the lever down or up, depending on if you're on grid power or generator power. And they even have this little manual lever here, so you could switch it manually by pulling it down. This is a lever here that you can manually actuate the transfer. But I'm not going to do that because this is all powered up and energized. And this lever handle stores right in there. Now, along with those power lines coming in from the generator up here, there's actually 4 little wires in there in the same conduit, which you can see here. And they come down and terminate on that terminal strip there, in the bottom of the strip right here. 2 of those say they're 12 volts DC, and 2 of them say they're 240 volts AC. Now what those are is signals to the generator and back from the generator. The 12 volt DC, as far as I can tell, operates this 12 volt relay here. And this 12 volt relay operates these solenoids that throw the transfer switch. So the control card in the generator turns that 12 volts on to tell that relay to transfer. And it probably holds that 12 volts on the whole time the generator is running, to hold this in the down position. In other words, generator power is selected. That 240 volt signal, there's 2 wires that equal 240. They get their power through those fuses there. And you can see some of these blue wires come across the top and actually go down inside here. And I think that 240 line there is what senses when the grid goes down. So when the grid goes down, these two lose power, and so this 240 signal here loses power. And when that 240 signal loses power, that's what tells the generator it's time to start up. I'm going to test that.
Let's look at the schematic. This is the 240 volt AC utility signal coming into the generator. And here's the 12 volt DC signal going out to the transfer relay. Here's the two hots going out to the transfer switch. And here's the neutral going out to the transfer switch. I colored the lines blue and yellow to represent the 240 volt blue and yellow wires in the transfer panel. Those connections land on a signal transformer internal to the generator cabinet. They cross the page and land on the control printed circuit board. When that signal turns off at the transfer panel, this is where the controller is notified the utility power is out. The other segment on the secondary transformer windings is tapped by wires 224A and 225A. Those end up supplying power to the battery charger. I've always wondered where the generator's onboard battery charger got its power from. A simplified calculation here. 56 VA plus 1 VA divided by 240 volts times 90%. Guesstimating the transformer efficiency at 90% approximates the 240 volt utility signal as slightly more than a quarter amp. Close enough for my purposes. We'll measure it later.
Okay, I'm looking at this label up here in the back. I'm going to read it. Generac Power Systems Transfer Switch Load Center number, whatever that number is. Let me get some light on the subject. OF 9085. Generac Power Systems Transfer Switch Load Center. Class CTL enclosed. Panel board. UL listed. Issue number HP-131-553. The date is not marked. Maquoketa, Maquoketa, Iowa, USA. I'm going to have to look up the pronunciation on that.
Maquoketa, 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 Maquoketa.
Then here, and then manual operation, interesting. To manually operate switch, attach handle to operating level between solenoid coils on left side of switch. Pull lever down to connect standby, or push lever up to connect utility to loads. When servicing has been completed, be sure to remove handle from switch. All terminal lugs are suitable for copper or aluminum of at least 75 degrees C rating. Replace with UL listed fuse of same type and rating, 600 volts, 5 amps. And that would be, I assume, those fuses, which are 5 amp fuses. Okay, so that manual operation of the transfer switch happens here. See that little yellow indication? Well, look what they have stored down here. a yellow handle. And that goes in there like this. So I'm not going to do it, but if you were to manually operate this, you would pull down on this and it would shift those solenoids. This one would be extended, this one would be retracted. Of course, that would be when there's no power on the system. And when you do that, you're also switching this transfer switch here from one power source to the other. So the power comes in the top here from the main panel, feeds through that switch, comes out the bottom of it, and hits the main lugs here. Those are hot. I'm going to be careful not to touch them. And then if this switch transfers, that the power comes from the generator into the bottom of the transfer switch, and then down here to the main lugs, or the sub-panel lugs. So that's basically how a generator transfer switch works. All right, let me put this back in its little storage slot here. So I hooked my meter up. One lead is over here on the neutral, and the other one is up there on one leg of the 240. You can see it right there. It's reading 121 volts. Then the other leg of the 240, let me hook it on there. That's also reading 121 volts. And now if I go across those two, well, let me just hold it. Yeah, there it is. There's the 240. And now I'm going to hook this up on the 12 volts, positive and negative. If I can get these leads on there. Okay. And right at the moment that's reading 0. I think that's going to turn on 12 volts to tell this to transfer. Okay, I'm going to do this test now. What I'm going to do is pull one of these 240 volt lines off. They're actually line 1 and line 2, 120 volts each. They combine to make 240. When I pull one of those off the terminal strip, I expect to see this go to 12 volts, and we're going to see that transfer switch actuate. Okay, so here we go, and I opened the cellar windows, so we should hear the generator start up. And the light's going to go out temporarily. You hear the generator? It's starting. The generator failed to start. It's going to retry. There it goes. There it is. Now the house is on generator power. I'll let it run for a few minutes. Interestingly, that 12 volt signal I expected to see here isn't here.
It was obviously a bad connection with the meter probe, because I'm going to try again, and it will work next time.
So there's something I'm misunderstanding about how this functions.
No, it was just a bad connection.
That LED light is strobing. I wonder what the power level is coming out of that generator.
And the frequency. I wish I had an oscilloscope.
I'm going to shut off the grid power in the main box and reconnect this line. Since I turned that power off, the grid power off, this line should be dead. No, it isn't. It's switched back. I don't quite understand how this functions, obviously. I'm going to turn that off. All right, we're back on generator power. Okay, the 240 is still off on there.
As it should be, with the main breaker turned off.
I want to see if I can get a more stable bulb here, maybe an incandescent. Oh, there, that's a better light. Those LED floodlights have a very strange behavior. And here maybe we can see with less glare that right now that 240 line is showing nothing on it. I'm going to turn the main breaker back on. And I have my 240 back on. Right here on the terminal strip from those two little wires. Those are the grid sensing wires for the generator. It switched back on to grid power. And after a minute, the generator should shut down. Okay. Well, anyway, that proved to me how I can remote control that generator by switching those 240 volt wires. Turn them off, the generator turns on. Turn them back on, the generator shuts down. Okay, I'm going to do another experiment. I have a feeling that these 12 volt wires since they didn't come on and stay on while the generator was running, they might be a pulse. It might pulse to transfer and then pulse to transfer again. That's what I'm thinking. And there's actually two limit switches on here, so the controller knows what position that thing's in.
I shouldn't have said that. The limit switches don't appear to be tied back to the controller.
We're still reading 0 on that instead of 12 volts. Okay, I'm going to shut off the power again. And I want to see if that 12 volts pulses, if we see anything at all on the meter. So here we go. Power's off. Of course, we can't see the meter. There, 13 volts on it right there. I hope the camera sees it.
So this proves I surmised correctly in the beginning. That 12 volt DC is holding the transfer switch in the generator supply position.
I'll let it run for a few minutes and then transfer it again. That 12 volt signal is still on. It's backwards. For some reason the polarity is negative on that. And I do have the probes connected to the correct one according to the label there. and I'm reading negative 13 volts. Okay. Going to turn the grid back on. It's back on. And the signal went off. So that is the signal that throws the transfer switch. We're back on grid power. And the generator continues to run. It runs for a couple minutes to cool down and then shuts down. And that's the whole sequence there. The sequence is controlled by these 240 volt wires here. So that whole sequence is initiated by these two little 240 volt sensor wires. The blue and the yellow there on the terminal strip. They send the signal to the generator controller that the power's out or back on. And then the controller does what it needs to do. It starts the generator when the power drops out here. The controller starts the generator. After it runs for 15 seconds or something like that, the controller sends the signal on these 12 volt lines to fire the transfer switch, and then we're on generator power. Then after the power, the 240 volts is restored, the generator turns that 12 volt signal off, and we transfer back onto grid power. And then the generator runs for a few minutes just to cool down, and then it shuts down. And that's the whole sequence. Okay, so here I am again. This is a couple days later. There's a couple more checks I want to do on this. For one thing, I want to see how much current is flowing on this 240 volt sensor circuit. So I'm going to hang a amp probe on there, and this one has a very not a great resolution. It displays 1 millivolt per amp, and right now it's displaying no millivolts, even though I know it's on. So that tells me it's probably pretty low current. Let's see, how about this? So leg 1 is 1 amp and leg 2 is 0. Let's see, I could put on some more load on this. Okay, the sump pump actually started up. Okay, there's 3 amps on that line and 2 amps on that one. So this sensor circuit, the current is too low for this instrument to pick up. This is really a 1 to 400 amp current clamp, so it's obviously way below 1 amp there. That's just on this sensor circuit, which I would expect. So now I'm going to hook this up in the circuit, in series with the circuit. This is the 10 amp fused amp meter function on here. I know it's way less than 10 amps, so this should be safe to do. And I'm going to get things hooked up and I'll come back. So I connected a jumper from the top of that fuse down to there, the bottom of that one blue 240 volt wire. That way I can disconnect that wire from the terminal strip without causing the generator to come on. It won't lose the 240 volt signal. Okay, so that's what I'm going to do. I'm going to disconnect this 120 side of the 240 volt signal from the terminal strip. And as long as that jumper stays on, the generator won't come on, because it'll have the 240 volt signal saying to stay off. It's basically what that signal says. Okay, I just wanted to make sure that was on there real good, which it is. By the way, don't try this at home. This is a hot 110 volts here from there to there. But now I'm going to hook up the amp meter and break that line. I'm going to hook up the amp meter so that it's in the line when I disconnect that jumper. Okay, so there's my two meter probes, amp meter probes. My Fluke meter is set to DC amps, reading 0, as we would expect. Alright, so now one of these probes, it doesn't matter which one, gets hooked to this there. The other one gets hooked to here. Take a little video so you can see what's going on. So one lead from the amp probe is connected here, and the other lead from the amp probe is connected here, the red one. So now when I disconnect that black lead, which is jumpered over to this terminal strip, the amp probe will be passing all the current that's in this circuit. And hopefully it's less than 10 amps, but we'll see. I'm about to disconnect it. And here we go. I'll hook this onto this plastic right here. And this is reading basically 80 milliamps, 0.08, 0.07, 0.08 amps. So this is an 80 milliamp signal, 0.080. That's what I wanted to know. Now I have to undo everything I did without starting the generator. Actually, it wouldn't matter if I started it, but I'll put this jumper back on here. That's jumpering the signal in so that the generator won't start. Pulled the positive lead, the positive lead. Pulled one lead off the amp probe, and here's the other lead off the amp probe. And now the only thing keeping that generator from running is this clip lead, which is jumpered over to here, onto that blue 240 volt line. It's actually 1/2 of 240 volts. It's a 120 volt line. Oh, and I left all the loads turned on, so good thing the generator didn't turn on. I can hear the sump pump is running again. So the sump pump is this one, so I'll turn all the rest of them off, except for the smoke alarms. Oh, and I'll leave my lights on. Okay, so right now I just have the lights on here and the sump pump. Oh, that's the smoke alarms. I better put those back on because they're beeping. The sump pump is stopped, so I'm going to turn that off. I'm doing this all just in case I lose the connection here, and maybe I'll just lose it intentionally. It'll be a lot easier to reconnect things with the generator running. So why don't I do that? Okay. The generator thinks the power's off. So I'll turn it off. And then the transfer switch came back on and put the power on. Alright, now I can reconnect this 120 volt signal. Of course, when I do that, the generator is going to go right off. So I suppose I should let it run for a minute. Don't want to just turn it on and off very quickly. I'll let it exercise a little bit and then I'll hook this back up and it'll shut down. But meanwhile, I can take this wire here and seat it in that strip better. I pulled it out somewhat to make it easier to clip to. Those lights are strobing just enough so that the camera can see it. That's that LED light again. That reminds me, I should check what is my voltage level when we're on the generator. Oh, it's plenty ample here. It's 247, 248. It's actually a little high. It's not low, so that's okay, I guess. Okay, I'm going to hook this signal back up, and the generator or the transfer switch will transfer right away, and the generator will run for a little bit. And now I'm going to turn the grid back on, turn the main breaker back on. That's going to switch. And we're back on the main, which means we're not drawing any power from the generator. And what's our main voltage look like here? Just out of curiosity. This is coming from the main panel now off the grid. 244. Okay, I learned what I needed to learn. I learned that 240 volt signal is actually only 80 milliamps. That's what I needed to know to be able to hook into that. I'm going to be adding another device that's going to control that automatically, and that device comes with a set of contacts to manually or automatically turn off and on the generator.
Here's a sneak peek. The EG4 18Kpv all-in-one inverter can be configured to control a generator with a standard internal relay. The normally closed contacts in this relay are rated for 3 amps at 277 volts AC. So I now know it's compatible with my Generac system.
And I'm going to be cutting that in onto this circuit. And now that I know it's such a small current, those contacts can handle 3 amps at 277. This is 240 at 80 milliamps. Not even a tenth of an amp, so it'll be perfectly fine just to use those contacts without adding another relay. So that's what I wanted to know here. It's time to button this up and get this video edited up and out there.
I said I'd show the inside of the cover, so here it is.
Okay, everything's turned back on. I'm gonna go ahead and put the cover back on.
Thank you for watching. Please take a moment to like and subscribe.
Alright, just to recap what we saw, those two 40 volt lines are what tell the generator that the power is either on or off. When the power turns off, the generator starts. Then after the generator runs for a little bit, it turns that 12 volt signal on, and that 12 volt signal controls the actuation of the transfer switch. So when 12 volts comes on, we transfer from grid to generator power, and it just runs that way. Then when the 240 volts comes back on, meaning the grid's back up, the controller in the generator turns the 12 volts off, which causes the transfer switch to go back to the up position, and we're back on grid power.